Hi everyone, welcome to my channel. I am Jumana Khanfar from Taqarub International Schools. In this lesson we will study dynamics. The word dynamics means the study of motion, or to study the actual causes of motion. For any object to move, there should be an unbalanced force. Now, to understand this, we need firstly to study everyday forces, the forces that we deal with every day. After that, we will learn how to construct the Freebody Diagram of an object. Which is a diagram that depicts all the forces affecting on an object, with some questions to illustrate that more. Then we will study Newton's laws of motion, the 3 laws. After that, we will take some special cases like the inclines and the compound body problems like the poly problems. So let's start. All forces in nature are classified into 2 main types: contact forces and non-contact forces. Contact forces require direct interactions between the objects, like when you pull or push something. And spring force, drag force, frictional force, the force of 2 surfaces rubbing against each other, and the normal force, all these forces are contact forces. They require physical contact between objects or surfaces. The second type is the non-contact forces, like the magnetic force, the electric force, the gravitational force. For example, if there is a piece of iron here, the magnet will attract this piece of iron, although it doesn't touch this magnet, but because it is close to it. And 2 positive charges can repel each other without direct contact between them. Now let's start studying the force of gravity. The force of gravity exists between any 2 objects, and it depends on their masses and the squared distance between them. But in this lesson, we will focus on the force of gravity that Earth exerts on you. Like this apple here is pulled down by Earth, and it is affected by a force called Fg. It's equal to its mass times the acceleration of gravity g. The direction of Fg is same as the direction of g, the acceleration of gravity, so it's always downward. G is 9.81 meters per second squared, but because we don't have calculators, or we're not allowed to use calculators on the SAT test, so we can use it as 10 meters per second squared approximately. If we have a box placed on a horizontal surface, this box has a mass of 5 kilograms, and please make sure that you differentiate between the word mass and the word weight. The mass is a scalar quantity. Actually, it represents the amount of matter an object has. Your mass on Earth is same as your mass on the Moon. But your weight is different on Earth and on the Moon because it's a vector quantity. It has direction, and it depends on your mass and the mass of Earth or the Moon. Okay, now, for this object here, on the horizontal surface, one of the forces affecting on this object is the force of gravity, and it's always directed downward. We calculate it by multiplying 5 times 10, which is 50 newtons. Also, if you have an inclined plane like this, force of gravity will always be downward. Downward doesn't mean in line with the surface or perpendicular to the surface. It's always toward Earth. This is the direction of Fg. If the object here on this surface is at rest, At rest means that the object is affected by balanced forces. There should be a force, another force, opposite to this force and equal to its magnitude. This leads us to the discussion of a new type of forces, which is called the normal force. In everyday life, the word normal means ordinary or usual, but in physics it has a specific meaning. It means perpendicular to the surface. Like this book here on the table is at rest. If it is at rest, it should be affected by balanced forces. Of course, it is affected by force of gravity down. So it should be affected by another force opposite to the gravitational force and equal to it in magnitude. It's a type of response forces. And it obeys Newton's third law of motion. For every action there is an opposite reaction. If I add another book here, Fg will be more. So Fn will increase as well with the same amount because it's a type of response forces. It's always perpendicular to the surface. Perpendicular means that the angle between the force and the surface is 90 degrees. For a box or any object placed on a horizontal surface, the force is upward. For an object placed on an inclined surface, the force is perpendicular. The angle between the force vector and the surface is 90 degrees. For something on the wall, for example, the force will be outward like this. This is the normal force. Actually, there is no specific formula to calculate the normal force, but you can calculate it from the other forces presented in the system. But look here, if we have a mass suspended from this wire here, do we have a normal force upward or not? Actually, normal force exists when there are two surfaces in contact. Here we have another force, the tension in the string. It is the force that the rope or the string here pulls the ball with. Tension force. Tension force is the force that a string or a rope applies on an object to pull it. For example, in this case, we have tension force here and here on this point. And the tension is the same in every part of a particular rope or string. Like the magnitude of tension here is equal to the magnitude of tension here because we have the same rope in between them. The tension is always out of the object and along the rope. Like in this case, this is the direction of the tension. This is tension. And if the object here is balanced or at rest, the tension will be equal to the force of gravity on this object. Now let's go to another type of forces. The elastic force, or the spring force, because the spring is the most common elastic material. If this is the original length of the spring, if I compress the spring, when I release the spring, it will go back to the right with a restoring force that is directly proportional to the displacement here. And to another factor depends on the type of the spring. So this restoring force that we call Fs, or the spring force, is equal to negative Kx. X is the displacement. This is the displacement in this case. And K is called the spring constant or the force constant. For example, a spring with a force constant of 40 newtons per meter will exert a force of 40 newtons when it is stretched or compressed by 1 meter. In this case here, the spring is stretched to the right. So the applied force is to the right. Then the elastic force will be to the left because it's a type of response forces. And again, it's calculated by this law, which is called Hooke's law. Now let's study another type of important forces in our everyday life. The force of friction. It is the force of two rough surfaces rubbing against each other. Some surfaces appear to be smooth, but actually if you zoom in, you see some imperfections in the surfaces. These imperfections are the cause of friction force. Now, suppose that you want to move a heavy object over a rough surface. As you apply your force to the right, the force of friction increases, which prevents you from moving the object. As the object is not moving, it is called static friction, or even if the object is moving at constant velocity. It is called static friction. At this point, as you can overcome the friction, it is called kinetic or sliding friction. So you have a different type of friction. This is the maximum friction, which is called Fs max, and here it is Fk. Fs is the static friction, Fk is the kinetic or sliding friction. The force of friction is calculated using this formula. Friction force equals mu times Fn. Fn is the normal force that we discussed earlier, and mu is the coefficient of friction. Mu depends on the type of material, and it does not depend on the surface area. A small piece of wood will have the same coefficient of friction as a bigger one. So it depends on the type of material, not the surface area. The frictional force is always opposite to the direction of motion. So if this object is moving to the right, the friction is to the left. Also, if you have an object on an inclined plane and this object is being pulled up by a string, the frictional force will be down the incline. The first step to solve any dynamic problem is to identify all the forces that affect that object and their directions. To do this, we use a graphical illustration by constructing a free-body diagram. The free-body diagram is a graphical illustration to describe and analyze all the forces acting on an object. It is called free because you take one object and draw all the forces affecting that object. Now let's solve this example. A 10 kg mass is pulled to the right along a rough horizontal surface by a string. Construct a free body diagram depicting all the forces acting on the mass. So we have an object placed on a horizontal surface. It is pulled to the right by a string, so this force is the tension. And because the surface is rough, there is a frictional force to the left. Okay, construct a free body diagram depicting all the forces. We have two other forces here, because gravity always exists on Earth. This is Fg, and in the opposite direction there is a normal force. This is the free body diagram that depicts all the forces on this mass. In the next video, inshallah, we will learn how to find the frictional force, the tension, the normal force, and Fg. Now, this mind map is a summary of everything we studied in this chapter so far. These are the different types of everyday forces. Firstly, the external force. The symbol F denotes any external force you apply, any push or pull force you apply on an object. The force of gravity Fg, or what we call the weight, it's equal to m times g. The normal force Fm, the force of friction with two types, static and kinetic, and it's equal to mu times Fn. The tension force, the force that exists when there is a string or rope. And finally, the elastic force, denoted by Fe or F as the spring force. In the next video, we will study Newton's laws of motion, and we will apply them on different problems to find the different forces. Thanks for watching.